Okay, Butin. Take your practical book. Take your practical book. Okay, this is practical number 11. This is practical number 11. Practical number 11. By the topic. Verification of the relationship between 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 the mass of a body the mass of a body suspended by helix spin, suspended by helix spin, and its period of oscillation, its period of oscillations. Verification of the relationship between the mass of the body mass of a body suspended by a helix spin and its period of oscillation. Okay, first we can look into the concept or theory behind the practical. Okay. Right. Right. The first topic, theory behind the practical. Right. You know, if we suspended a mass by a helical spring with a spring constant of K, and if we oscillate this one, if we oscillate this helical spring, the period of oscillation, is equal to 5 square root m over A. No? Correct. We know this now. So, this is the relationship between the period of oscillation and the mass of the body. So, this is the mass of the body. So, this is the period of oscillation. Therefore, we know this is the relationship between the period of oscillation and the mass of the body. So, we need to verify this one, not proving. We are not going to prove this one. No, we are going to verify this one. That means we have to use this equation and we have to verify this equation. We have to verify this equation is a true or is a validate equation. Okay. Therefore, this is a verification of this relationship using experimental method. Okay. I think you can understand this. So this is not a proof. Proven of this or determination of this relationship. Okay, we have to use this relationship to verify its validity. Validity. Okay. Did you get that? එක තේරෙනවද උස්සන්න? මොකද්ද මේ කරන්න යන්නේ කියලා? අපි දැන් මේක prove කරන්න යන්නේ පුතේ. මේකේ validation එක අපි verify කරගන්න යන්නේ experimental setup එකේ. හරි? Okay. Therefore, we can use this relationship with it. So actually, if we are going to determine this relationship with it, we cannot use this relationship. We have to prove from the basic. So that is a theoretical part. So we are not going to prove this relationship. We are going to verify this relationship using an experimental method. Okay. Now, you know this is the relationship between period of time or period of oscillation. So period of oscillation and M. So if I square both sides, T squared is equal 4 5 squared over K into M. Into. So if you change the mass hung by the spring and measure the time or measure the period of oscillation. If you change the mass suspended by the spring and measure the period of oscillation separately, and if you plot M versus T squared graph, if you plot M versus T squared graph, definitely this should be y equal mx type graph. Y equal mx type graph. How to say that part? So it is very clear 4 5 squared is a constant. K means spring constant. Therefore, that is a constant for particular spring. Therefore, this part is a constant. This part is a constant. As this part is a constant, T squared is directly proportional to it. T squared is directly proportional to it. Therefore, if I plot a graph between M and T squared, definitely should be y equal mx type graph. Y equal mx type graph because you know 4 5 squared over K, that is a constant. That is a constant. So you know this is the mass and this is the spring constant. If you got this one, very good. Very good. මම මේ කියන දේවල් හොඳට තේරුම් ගන්න පුතේ මම මේ ආයෙ කියනවා මීට කලින් මේ වගේ කතන්දර කියලා ඇති විශේෂයෙන්ම ප්‍රැක්ටිකල් කතන්දර වලදී දැන් මම ආයෙත් මේගොල්ලෝ තාම මේක ඕගොල්ලන්ගේ අර ඉනිෂියල් ස්ටේජ් එකේ පුතේ ප්‍රැක්ටිකල්ස් වල ඉනිෂියල් ස්ටේජ් එකේ මේ ආයෙ මේ කතා කරන්නේ හරි මට මේකට ආන්සර් එකක් දෙන්න. So what is the independent variable of this relationship and what is the dependent variable of relationship? What is the independent variable? First, let me know what is the independent variable. What is the independent variable? What is the independent variable of this relationship? Yes, very good. Yes, you are correct. My next question is, how do you identify whether it is the independent variable or not? How do you identify? How do you identify? Yes, M is the independent variable. M. Yes, M is the independent variable. My question is, how do you identify that one? How do you identify that one? මම මෙතන මොඩියා වගේ කිලිම x දැම්ම ඉතින් ඒක නිසා ටක් ගාලා කියන්න පුළුවන්. හරි. මේක identify කරේ කොහොමද කියලා කියන්නේ? Independent variable එක මේකයි කියන්නේ. මට අන්න ඒකයි ඕනේ. අපිට එහෙම identify කරගන්න බෑ. මතක තියාගන්න independent variable එක හරි yes independent variable is not dependent on any other factors. But we cannot say like that. We cannot say like that. We cannot identify like that. When we are doing an experiment, when we are doing an experiment, we cannot identify an independent variable using the definition. There is a problem. There is a problem. When we are doing an experiment, we cannot identify the independent variable using the definition. So how do you identify that thing? No. මෙතන ලේසි. මෙතන ඔයාලට ටක් ගාලා කියන්න පුළුවන්. ඒක වෙනම කතාවක්. නමුත් සමහර තැන් තියෙනවා. දැන් අපි ඉස්සරහට යනවා මම ඕගලන්ට එවන්න ඔය ඊළඟ එක්ස්පෙරිමන්ට්ස් ටික. සමහර එක්ස්පෙරිමන්ට් එනවා මොකක් කරත් හරියන්න පුළුවන් තැන් තියෙනවා. මොකක් කරත් හරියන්න පුළුවන් තැන් තියෙනවා. හරි. ඒ වගේ තැන් වලද ඔයගොල්ලෝ කියන කතන්දරේ මේ හරියන්නේ නැහැ. එහෙම නෙමෙයි මේක බෑ. No පුතේ. මතක තියාගන්න මේක හොඳට තේරුම් ගන්න මම කියන හොඳට තේරුම් ගන්න. පුතේ when you are doing a practical you are going to change some certain factor some certain variable. හරිද ප්‍රැක්ටිකල් එකක් කරද්දී ඔයා මොකක් හරි variable එකක් change කරන්න ඕන පුතේ. හරිද? Then by changing that variable you are going to measure another variable. Hariද? In practical you are going to change some variable. By changing that variable you are going to measure another variable. Hariද? Therefore the independent variable means the first variable that you are going to change. That is the independent variable. That is the independent variable. According to change of that variable, the measured variable, the variable to be measured, is called the dependent variable. But here we are going to change the mass. Here we are going to change the mass and measure the period of oscillation. We are going to change the mass and then measure the period of oscillation. Otherwise, we cannot measure the period of oscillation. Therefore, this should be the independent variable. This should be the independent variable. Yes, independent variable does not depend on any other factors. Yes, that is correct. That is correct. But my question is not that. My question is not the definition of independent variable. My question was, how do you identify the independent variable during this experiment? How do you identify that thing? Because when you are preparing this relationship into a graphical format, you need to identify that thing. Okay? So, when you are preparing an expression for a graphical format, we need to identify what is the independent variable and what is the dependent variable. Because we know actually there's a standard. We know there's a standard we have to represent the independent variable in x-axis, the dependent variable in y-axis. Therefore, definitely, you have to identify the independent variable and put it in x-axis. And put the dependent variable in the y-axis. That should be must. That is a must put it. Therefore, we have to identify. You have to identify what is the independent and what is the dependent variable. And again, how do you identify? How do you identify the dependent variable and independent variable during the practical or during experiment? How do you identify with it? The variable or the factor that we are going to change during the practical is the independent variable, and the variable that we are going to measure by changing the first factor is called the dependent variable. Is that clear? ඒක තේරෙනවද තුස්සන්? ඒක තේරෙනවද තුස්සන්? ඒක පැහැදිලිව නතුසේ. ඒක මාරම වැදගත් කතන්දරයක් මම මේ කිව්වේ. එහෙම නැතුව අඳුරගන්න බෑ ඕගොල්ලන්ට මොකද්ද x axis එකට දාන්න ඕනි, මොකද්ද y axis එකට දාන්න ඕනි. So once you identify the independent variable and the dependent variable, Puthe, you can rewrite this expression. You can rewrite this expression as y equal mx plus c pattern. එහෙනම් මේක arrange කරගන්න ඕනේ y equal mx plus c pattern එක arrange කරගන්න ඕනේ. හරි. මෙතන arrange කරගන්න දෙයක් නැහැ පුතේ. මෙතන ගෙලිම මේ පැත්ත y මේ පැත්ත x කියලා ඇවිල්ලා තියෙනවා. නමුත් ගොඩක් ඒවා එහෙම එනවා අඩුයි. ගොඩක් relationships වල එහෙම එනවා අඩුයි. අපිට මෙහෙම මාරු කරන්න ගන්න නෙවෙයි, සමහරවිට reciprocal එක ගන්න වෙනවා. ඔය කතන්දර ගොඩක් තියෙනවා. හරි. සමහර තැන්වල reciprocal එක ගන්න වෙනවා. ඒ වගේ තැන් ගොඩක් තියෙනවා. හරි. සමහර තැන්වල 1 over යම් කිසි fact එකක් ගන්න වෙනවා. ඒ වගේ තැන් ගොඩක් තියෙනවා. හරි. Therefore, in this case, it is not a issue. It is not an issue, Puthe. That is very easy. So it is very clear we are going to change the mass hung by this spring and then measure the period of oscillation relevant to that mass. Therefore, we are going to change the mass, and by changing the mass, we are going to measure the period of oscillation. Therefore, this should be the independent variable. Therefore, we can put it as x. So this is the dependent variable. Therefore, we can represent it in y-axis, and this is the variable. This is the variable. Therefore, if you change the mass and measure the period of oscillation, and if you plot m versus t squared graph, if you plot m versus t squared graph, it should be y equal mx type graph. Therefore, if you plot m versus t squared graph, it should be y equal mx type graph. It should be y equal mx type graph. Therefore, if you got this kind of graph, we can verify this relationship is valid. Is that clear? ඔන්න අපේ වෙක්ටර් සෙට්. Okay. මේක දාන්න. දැන් මම ඔයගොල්ලන්ට මේවා කියාදිදී යන්නේ බොහොම සිම්පල් විදිහට ඉස්සරහට යද්දි ප්‍රැක්ටිකල් එකදී ආයසද මේක තමයි ඉන්ඩිපෙන්ඩන්ට් මේක මෙහෙමයි වෙන්නේ. එහෙම කතන්දර නෑ. ඩක් ගාලා ගත්තා මේක තමයි ඉන්ඩිපෙන්ඩන්ට් වෙරියබල් එක කියලා නිකම්ම අපි කතා කරනවා. එතකොට ඔයගොල්ලන්ට ඒක අන්ඩර්ස්ටෑන්ඩ් කරගැනීමේ හැකියාව තියෙනවා. ඇයි මේක ඉන්ඩිපෙන්ඩන්ට් කරේ කියන්නේ? ඇයි මේක ඩිපෙන්ඩන්ට් කරේ කියන්නේ? ඒක තේරුම් ගන්න පුළුවන් වෙනවා. ඒ නිසා හොඳට මම මේ මුල් ටිකේ බොහෝම සරලව බොහෝම හිමින් කතා කරන දේවල් අල්ලගන්න. මොකද ඉස්සරහදී අපි ඒවා ඉස්සරහ ඇප්ලයි කරනකොට ආයි කියන්නේ. Okay, have you finished? There are none of this. Change the suspended mass, change the suspended mass and measure the period of oscillation. Measure the period of oscillation. Measure the change the suspended mass and measure the period of oscillation relevant to that mass. Relevant to that mass. Full stop. Then plot the graph between m versus t square. They plot the graph m versus t square. They plot the graph m versus t square. If the graph is y equal mx type straight line, if the graph is y equal mx type straight line, if the graph is y equal mx type straight line, if the graph is y equal mx type straight line, the above relationship can be verified. The above relationship can be verified. මේ ප්‍රැක්ටිකල් එක මහලුක අමාරු ප්‍රැක්ටිකල් නෑ බොහොම ලේසි ප්‍රැක්ටිකල් එකක් පුතේ. Okay. Then I the second topic, materials and apparatus. Materials and apparatus. First we require a helix spring. To a set of 50 gram weights Number three, a stopwatch. A stand. An indicator. A locating pin. A locating pin. Already covered. Those are the materials and apparatus we need to have during this experiment. Materials and apparatus. Then the proceeding. The next topic is proceeding. So this is our setup. This is a stand. Then this is stand today. So we can suspend this mass by this spring, and the entire system can be hung in this stand. Okay. So during this process, today we have to attach an indicator. We have to attach an indicator to this mass. This is the indicator. They පුළුවන් තරම් try කරන්න vertically sorry horizontally set කරගන්න මේක. So this is the indicator. Then we have to locate a locating pin. අපි කියන locating pin actually. We have to locate a locating pin. In line with this indicator. එදක in line වෙලා තියෙන්න ඕනි. මෙහෙම කියන්න බෑ. හරිද? So this is the stand today, this is the indicator, this is the locating pin. This locating pin can be moved up and down today. This can be moved up and down. ඒක දාගන්න ඕනේ නේද? stand එකේ දී උඩ පල්ලෙහාට ගෙනියන්න. එයාට ටෙස්ට් එක කරනකොට කෙතන ෆික්ස් කරගන්න ඕනේ. ටෙස්ට් එක කරනකොට කෙතනක ෆික්ස් කරගන්න ඕනේ. Okay, therefore is the mass helical string stand and okay, this is the locating pin. Locating pin, and this is the indicator. This is the indicator. Indicator. Okay. So actually, this locating pin and the indicator is used to measure the number of oscillations. Number of oscillations. And because if we pull this mass a slighter, if we pull this mass slightly and release it, this will vibrate. This will vibrate. This will vibrate. Therefore, we can measure the number of oscillations using this locating pin. And මේක මෙතන කියලා පිළිදානකො locating pin එක. මේක තමයි අපි indicator එක. Indicator එක උඩට ගිහිල්ලා පල්ලෙහාට ඇවිල්ලා ආයෙ මෙතන එනකොට ඔන්න එක රවුන්ඩ් එක. ආයෙ මේක උඩට ගිහිල්ලා පල්ලෙහාට ඇවිල්ලා ආයෙ පිට එනකොට රවුන්ඩ් දෙකක්. ඒක නිසා මේ locating pin එකයි indicator එකයි use කරලා මට බලා ගන්න පුළුවන් number of oscillations ගන්න. Number of oscillations. Today, actually, you need to determine the period of oscillation. You need to determine the period of oscillation because this is our relationship. This is our relationship. T squared is equal 4 pi squared over A into N. Therefore, you need to suspend a certain mass and then you have to pull this mass slightly in downward direction and release. Then you need to determine the period of time, period of oscillation, period of oscillation. Period of oscillation means time taken per one oscillation, time taken per one oscillation. And then you need a stopwatch. Now you need a stopwatch. Therefore, you have to slightly pull this mass in downward direction and release. Then determine the time taken for an oscillation. For an oscillation. That is very hard and that is not accurate. So what is the reason? Time taken for one oscillation is not an accurate thing. So what is the reason for that one? Can anyone tell me? Time taken for one oscillation is not an accurate measurement. So what is the reason? Can anyone tell me? අපි මෙහෙම ඇත්තලා අතහැරලා එක oscillation එකකට මම time එක මනින්න. T. ඇයිද M එක මනින්නලු T නේ? M සාදීනේ මනින්න. එක oscillation එකකට time එක මනිනවා කියන එක ඇත්තට practical scenario එකක් නෙවෙයි පුතේ. ඇයි ඒක? What is the reason? Not human errors. Yes, human errors can be happen. You means measuring time, no? Yes, measuring time, human errors can be occur. Yes, very good. Yes, Satish. Right. Today, if we consider about one oscillation only, the time taken is very, very small. Very, very small. sometimes we cannot measure the time correctly. Yeah, as you told you, yes, there may be human errors. ඇදලා අතරපු ගමන් අපිට ස්ටොප් වොච් එක ගන්න පරක් වෙන්න පුළුවන්. And therefore there may be huge human errors. On the other hand, the measurement is very, very small. If the measurement is very small, the fractional error very high, Puti. The fractional error very high. Therefore, taking the period of oscillation, taking the period of oscillation per one oscillation is not an accurate method, Puti. It's not an accurate method. Use करने के अच्छा होता है. Yes, Puti. देखा था. ඒ ඔක්කොම එක එකතු වෙන්නේ මොකද්ද? error එකක් එකතු වෙන්නේ. ඒ error එක තමයි fractional error එකට එන්නේ. ඒ error එක තමයි fractional error එකට එන්නේ. And therefore we have to consider a certain number of oscillations. So instead of determining the period of oscillation, we are going to take the time for certain number of oscillation. Let's say it's a 50 or 30 or something. Therefore, we need to count 50 oscillations. And we need to count 50 oscillations. So once you pull this, once you pull this mass in downward direction and release it, then you need to count the oscillation, number of oscillations. So when you are counting oscillation, you can use the locating pin and the indicator. So once the full circle is completed, you can count it as 1. Then second count, third count. Likewise, we can count the number of oscillations. Then we are going to measure the time taken for 50 or 30 number of oscillations. The number of oscillations. Then if that number is 50, if time taken for 50 oscillation is equal to 50, then time taken for one oscillation can be determined by dividing that value by 50. Dividing that value by 50. Is that clear? Tena to son. අපි ඒක කරන්න හේතුව ඇයි? fractional error එක. ඒ කියන්නේ time එක මන්නකොට සිද්ධ වෙන fractional error එක පුතේ අඩු කරගන්න. මොකද time එක මන්නකොට oscillation period එක ගත්තොත් එහෙනම් මේක ගොඩාක් පොඩි value එකක්. එතකොට ඒක measure කරනකොට වෙන error එක ගොඩක් වැඩි. Therefore, to reduce that error, we need a large number to measure. That's why we use time taken. We use the time taken for 50 oscillations. That number can be determined today. So how to determine that number is we need to keep the fractional error less than 1%. We need to keep the fractional error. We need to keep the fractional error less than 1%. So that we can calculate the number of oscillations required to do that. And අපි දන්නා අපිට කොහොමද fraction එක ගමන්නේ? මට කියන්නේ කොහොමද fraction එක ගමන්නේ? again fraction එක measure කරන්න කොහොමද? Yes, least count fraction error least count divided by උදාහරණයක් එක ෆ්‍රැක්ෂනල් එක පර්සන්ටේජ් එකක් වශයෙන් ගත්තොත් දැන් ෆ්‍රැක්ෂනල් එක ගත්තොත් එහෙම අපි සාමාන්‍ය ෆ්‍රැක්ෂනල් එකක් කියලා ගන්න එක එයාගේ පර්සන්ටේජ් එක 1% වලට වඩා අඩු වෙන්න ඕන. හරි 1% පොයින්ට් වඩා අඩු වෙන්න ඕන. ඒක නිසා මම මෙයාගේ ෆ්‍රැක්ෂනල් එක 1% කියලා ගත්තොත් කියන්නේ 1 over 100 කියලා ගත්තොත් අපි දන්නවා ලීස් කවුන්ට් එක ස්ටොප් වොච් එකේ දැන් අපි බලන්නේ ස්ටොප් වොච් එකේනේ ටයිම් එක කරවන්නේ. ටයිම් එක කරවන්නේ. Therefore, least count means that is the least count of the stopwatch. Least count of the stop. Divided by measurement. Measurement means time taken for 50 oscillations. I don't know number of oscillation. Now I am going to determine that number today. Suppose we are going to measure n number of oscillations. Suppose now we are going to measure n number of oscillation. And so time taken for one oscillation, suppose time taken for one oscillation, that means period is capital T. And period day capital T, n number of oscillations gonna measure. Therefore, our total measurement should be n into T. T means time taken for one oscillation. This is number of oscillation. Time taken for one oscillation, number of oscillation. So this is the least count. So normally we are given the least count. Therefore, we know this thing. Least count of the stopwatch is a non-value because when you are taking a measuring instrument that is rated to be. That is rated. Therefore, there is the least count. Therefore, we know this thing. And suppose that value is x. Therefore, I can write this one plus 1 over 100 over x over 80. That means n is equal 100x over 80. So 100x over 100x over 80. පැහැදිලිද? තේරෙනවද උස්සන්න? මොකද අපි මෑත්ස් එක දන්නවා ඩක් ගාලා k වැලියු එක දන්නවනම් අපිට ඩක් ගාලා t හොයාගන්න පුළුවන් කැල්කියුලේට් කරගන්න පුළුවන්. ඒ නිසා එක්ස්පෙරිමන්ට් එක කරන්න කලින් මට අවශ්‍ය මිනිමම් ඔසිලේෂන්ස් ගන්න හොයාගන්න පුළුවන්. මේක තමයි මට ඕනේ මිනිමම් ඔසිලේෂන්ස් ගන්න. මේ ඔසිලේෂන්ස් ගන්න මීට වඩා වැඩි වුණොත් මීට වඩා එරර් එක අඩු වෙනවා. මීට වඩා එරර් එක අඩු වෙනවා. හරි. Therefore, this is the minimum number of oscillation we need to have during this oscillation. මට මේක තේරුණා නම් මේ ගත්ත එක තේරුණා නම් තුස්සන්න. මේ ගත්ත එක තේරුණා I need responses from everyone. පැහැදිලි නම් තුස්සන්න. සාසලෙකදී මෙසලු ප්‍රශ්න හරි. Okay. Thank you. එහෙනම් මේ විදිහට මට n කැල්කියුලේට් කරගන්න පුළුවන්. මේ විදිහට n කැල්කියුලේට් කරගන්න පුළුවන්. දැන් මෙතන අපි ඔයගොල්ලෝ ප්‍රැක්ටිකල් බුක් එකේ තියෙනවා 50 number ඔසිලේෂන්ස් ගන්න කියලා. ඒ නිසා ඉතින් අපි මේකට 50 කියලා කතා කරලා හදාගන්න පුළුවන්. ඒ වුණාට අපිට පුතේ ඇත්තටම n කැල්කියුලේට් කරගන්න පුළුවන් මේ විදිහට අපිට අවශ්‍ය නිසා. හරි. හරි. ඔය විදිහට n කැල්කියුලේට් කරගන්න පුළුවන්. ඕක තමයි ප්‍රැක්ටිකල් එක පුතේ. මේක තමයි ප්‍රැක්ටිකල් එක. දැන් ප්‍රැක්ටිකල් එකේ අපි ඊළඟ ස්ටෙප්ස් එක බලමු. ක්වෙස්චන්ස් එක ඇසුරේ මම ඒ ටික එක්ස්ප්ලেইন කරන්න. Okay. Now we are going to discuss about procedure. Therefore, please flow this one. Only this one. Do not write anything. Do not write anything. Okay. I finish. I finish. මෙච්චර මෙයා මුකුත් ලියන්න එපා. මෙයා මුකුත් ලියන්න එපා ආයෙසරක් මෙයා මුකුත් ලියන්න එපා. Just draw the practical setup. Okay. There are the procedure. Number one. Fix the experimental setup as in the figure. Fix the experimental setup as in the figure. Number two. Fix the indicator. Fix the indicator horizontally. Fix the indicator horizontally at the end of the sprint. At the end of the sprint. That one. When the spring is in rest condition, when the spring is in rest condition, place the locating pin, place the locating pin when the spring is in rest condition. When the spring is in rest condition, place the locating pin in line with the indicator. In line with the indicator. Add 50-gram mass to the mass attachment or mass holder ke la. Mass holder ke la. Add 50-gram mass or wait for the add 50-gram mass to the mass attachment. Okay, this is spring attachment or this is spring. It's like this. මෙතන පුතේ තියෙනවා නිකන් අර මුද්දක් වගේ එකක්. හරි. ඒකට මේ mass attachment එක දාන්න පුළුවන්. මේ mass attachment එක මෙන්න මෙවයි. So this is the mass attachment. පුතේ මේකට මට වෙන වෙනම weights දාන්න පුළුවන්. ඒ weights වල තියෙන මේ වගේ පොඩි මේ glue එකක් කපලා. මේ වගේ. ඔනවා glue එකක් කපලා තියෙනවා set එකක් කපලා තියෙනවා. So we can insert this mass into this vertical bar. මේ vertical bar එක set එකේ තියෙන විදිහට මම mass එක දාන්න පුළුවන්. මෙතන මේ vertical bar එකට set වෙන විදිහට මොනවද තියෙන්නේ. Therefore, we can insert this mass into this mass attachment. Is that clear? Take the terus. Therefore, this is the mass holder. Now this is the mass. 50 gram mass. Where? ඔන්න ඔය විදිහට තමයි. හරි. ඊළඟට පුතේ මේක දාලා දැන් අප ඔසිලේට් කරනකොට හොඳට මතක තියාගන්න you have to pull the weight. You have to pull the weight very slightly. Don't pull it in a huge amount පුතේ. ලොකු ප්‍රමාණයකින් වැඩි කර මේ pull down කරන්න එපා. Slightly pull down. Slightly pull down. The other thing is you have to pull down the mass vertically downward direction. You have to ensure that thing, vertical downward direction. Because if you incline that thing, then there won't be any vertical vibrations. And everything අරහෙට මෙහෙට පැන ඉදී හතර මටේට vertical vibrations එකක් නැති වෙයි. Therefore, you have to pull down vertically in this case. You have to ensure that thing. The next point. Pull down the suspended mass slightly. Pull down the suspended mass slightly. And then release the sister. Next point is measure the time taken for 50 oscillations. Measure the time taken for 50 oscillations. And measure the time taken for 50 oscillations and then determine the period of oscillation. And then determine the period of oscillation. Pull down pull down the suspended mass sorry මම වාසල repeat කරන්නේ මම repeat කරන්නේ කලින් මොකක් හරි එහා මෙහා දාලා ලියා ගන්න. Pull down the suspended mass slightly and then release it. And then release it. ඒ වගේම පොඩ්ඩක් වෙනස් වෙන්න පුළුවන්. ඊළඟ measure the time taken for 50 oscillations. Measure the time taken for 50 oscillations. Measure the time taken. Measure the time taken for 50 oscillations. And then calculate the period of oscillation. And then calculate the period of oscillation. ඊළඟට මොකද කරන්නේ? ඊළඟට දැන් අපි හරි දැන් මෑත්ස් එකත් අපි දන්නවා හරි පීරියඩ් of oscillation එකක් දන්නවා ඒක හරි ඒක මෙෂර් කරගත්තා. ඊළඟට මොකද කරන්නේ? The next step is we have got another weight. We have got another weight. So once we add another weight, what will happen? That indicator means when the suspended mass is at rest condition, the indicator goes down. Therefore, we have to adjust the locating pin accordingly. We have to adjust the locating pin accordingly. Okay, one. That means, so once we increase the number of masses, initially there was only one mass. Now I have add another mass. Now there are two masses. Therefore, suppose initially, this is the initial state put it. Therefore, this was the indicator and this was manufacturing. This was the indicator and this was the locating pin. This is the locating pin and this is the indicator. So, if you add another weight, what will happen? This will stretch. So, this will stretch and therefore this locating pin will go down to the. Therefore, once you add another weight, so you have to wait until the object is in the equilibrium condition. So you have to put this weight into the equilibrium condition. Then you can identify now the equilibrium condition has changed into the downward direction. Therefore, you have to take the locating pin. You have to take the locating pin in downward direction. You have to take the locating field into the downward direction and in line with this field. And then make it then make equilibrium position එක මේක. මේක weight එක වැඩි කරගන්න තමයි equilibrium position එක වෙනස් වෙනවා. දැන් මෙතන තමයි බලන්න. දැන් මෙයාගේ period of time එක තමයි බලන්න. And therefore when you add the mass, when you are going to add the mass, remember definitely the equilibrium position will go in downward direction. Therefore, once you add the mass, you have to bring the indicator, or you have to bring the locating pin. You have to bring the locating pin in downward direction to locate it in line with the indicator. ඒක තේරුණා නේද ඔස්සන්? මොකද වෙන්නේ weight එක add කරපු ගමන් මොකද වෙන්නේ මුඩි equilibrium position එක පල්ලෙහාට යනවා පුතේ. එතකොට මොකද කරන්නේ මේ මොකද මේ indicator එක පල්ලෙහාට යනවා. ඒක නිසා මම මොකද කරන්න ඕනේ දැන් මේකද දැන් equilibrium position එක. දැන් මේක තමයි අලුත් equilibrium position. එහෙනම් ඒක මට හරියට වඳුර ගන්න මම කරන්න ඕනේ මේ locating pin එක ආයෙත් පල්ලෙහාට ගෙනල්ලා මෙයත් එක කෝ line කරනවා. inline කරනවා. So initially this was the puti equilibrium position. Now this is the equilibrium position. The locating should be placed at the equilibrium position. ඒක තේරෙනවද උස්සන්? හොඳයි අපි සාමාන්‍ය පුතේ අපි අර precaution එකක් විදිහට මොකක් හරි එකම අපිට දෙපාරක් එක්ස්පෙරිමන්ට් එක අපි කරනවා පුතේ. මොකක් හරි එකම එකක් ගත්තොත් ඒක අපි එක්ස්පෙරිමන්ට් එක දෙපාරක් කරනවා. මොකද සමහරවිට මේකේ එන errors ටික වැඩි errors ටිකක් එන්න පුළුවන් නිසා. අපි ගත්තා. Then add another mass. Then add another mass to the mass holder. Then the equilibrium position will go down. Then the equilibrium position will go down. Therefore, the locating pin must be lowered. Must be lowered. Must be lowered to keep it in line with the indicator. To keep it in line with the indicator. Okay. හොඳයි. පුතේ සාමාන්‍ය අපි එක weight එකකට අපි ඇත්තටම මේ මොනවද period of oscillations දෙකක් අපි සාමාන්‍යයෙන් ගන්නවා. හොඳයි. මේක දාගන්න. Next point. For a particular mass, we measure the time taken in two occasions. We measure the time taken in two occasions. Alright. Please draw this one. Maybe that can. Okay, have I finished with it? Have I finished? Okay. We can repeat the experiment. By adding 50-gram weights, we can repeat the experiment by adding 50-gram weights to the mass order. To the mass order. Next point, then we can plot the graph. Then we can plot the graph m versus t square. M versus t square. M versus t square. Then we can plot the graph m versus t square. Uh, I'm questions on questions here. Questions. Question number one. How do you count the number of oscillations? How do you count the number of oscillations? How do you count the number of oscillations? කොහොමද අපි count කරන්නේ? How do you find the how do you count the number of oscillations with it? So in such case, we have to use the indicator and the locating pin. We have used the indicator and the locating pin. Once the indicator completes the full circle, we can count it as 1. Once the indicator completes 2 circles, we can count it as 2. Likewise, we can count down the number of oscillations. We can count down the number of oscillations. By using the indicator, and the locating pin, we can count the number of oscillations. By using the indicator and the locating pin, we can count the number of oscillations. Alright. How කොහොමද measure කරන්නේ? ලියන්න. When the oscillation completes a full circle, we can count it. Question number three. What is the reason to measure the time taken for 50 oscillations? What is the reason to measure the time taken for 50 oscillations instead of one oscillation? What is the reason to measure the time taken for 50 oscillations instead of measuring it for one oscillation? මොකද හේතුව? Then we can increase the measurement. Then we can increase the measurement so we can reduce the fractional error. Write down this thing. Then we can increase the measurement. Then we can increase the measurement so we can decrease the fractional error. Next question. Next question. නෑ මම ඇහුවේ ඒ කියන්නේ 50 ගන්න එක ඊට පස්සේ තමයි දැන් ඊළඟ question එක දෙන්නේ. ඊළඟ question එක ගන්න. How to determine the minimum number of oscillations required during this experiment? How to calculate the minimum number of oscillations required for this experiment? There are let's go there. We have to keep the measurement. We have to keep the fractional error of the measurement. We have to keep the fractional error of the measurement lesser than 1/100. Lesser than 1/100. Okay, there are this one. Hello. Have I finished? Yes, period of oscillation ikat dagan. Here T means period of oscillation. Oscillation, no. I have taken for one oscillation. N equal number of oscillation. Number of oscillations. X means least count of the stopwatch. Hello. Okay, they write in expression. How do you calculate simple K? How do you calculate simple K using the above graph? How do you calculate simple K using the above graph? Okay, look at this one. So we know this graph is plotted between the span and M. So it is very clear it should be y equal mx type graph. So according to our relationship with the F is equal according to our relationship, sorry, not F. According to our relationship, gradient, yes. Relationship T square is equal 4 phi square over K into M. So this is our relationship. Pute, this is our y value, this is our gradient, and this is the extent. Hold on. Gradient measure growth. So if I measure the gradient, if I measure the gradient, if I measure the gradient, gradient is equal 4 phi squared over K. 4 phi squared over K. Therefore, K is equal 4 phi squared over F, or 4 phi squared over tan theta dua tahu. So this is the way of determining K. Tera pusat lagi. Okay, tanggal lagi. Okay. Pute, during this experiment, you are going to measure M and T. No? Those are the only two values. No? You are going to measure M and T, mass and time. So, among those two factors, or among those two variables, what should be the variable that has to be measured much accurately, more accurately. මොකක්ද මම measure කරන්න ඕන උඩටම accurate විදිහට measure කරන්න ඕනි variable එක මොකක්ද? m ද t ද? නැත්නම් දෙකම. කවුද වැඩිපුරම influence එකක් කරන්නේ මේ experiment එකට මොන measurements එකද? මොන measurement එකද? Yes, what is the reason? What is the reason? Not input. It should be T. It should be T. Why? What is the reason to measure the time much more accurately? So what is the reason? What is the reason to measure the time much more accurately? That is the most considerable factor during this experiment with it. It is very clear we have to square the time. We have to square the time. That means there are two T's. There are two T's for T. T into T. Therefore, if there is an error in that measurement, there's error in this measurement also. And therefore, when we are multiplying multiplying the same variable, and suppose the error of this variable is delta t, and error of this variable, delta t දෙන්නම ඒ කියන්නේ මේක මෙෂර් කරනකොට delta t කියලා error එකක් හැදෙනවා තියෙනවා. දැන් මෙතන t එක දෙකක් තියෙනවා පුතේ. t එක එකම t තමයි තියෙන්නේ. හරි. t square කියලා කියන්නේ t square means t into t. t into t. ඒක නිසා එක t එකක් මෙෂර් කරනකොට error එක delta t නා. දැන් delta t වල දෙකක් තියෙනවා පුතේ. එහෙනම් total error එක වෙන්නේ delta t වල දෙකක් තියෙනවා. 2 times delta t. Right. මෙතන මන්නකොට delta t කියලා error එකක් කියනවා. මෙතන මන්නකොට delta t කියලා error එකක් කියනවා. එහෙනම් delta t කියලා errors දෙකක් අපිට එහෙමනම් අපිට වැඩිපුරම error එකක් එන්නේ t measure කරන. t measure කරනවා. මතක තියාගන්න ඔය වගේ මොකක් හරි power එකක් තියෙන එකක් ආවොත් ඒ power එකක් තියෙන ඒ වැදී මොකද වෙන්නේ errors එකතු වෙනවා. හරි එකම fact එක කීප පාරක් measure කරනවා වගේ නේ පුතේ. මේ fact එක මේ කීප පාරක් measure කරනවා වගේ තමයි මේ තියෙන්නේ. මේ time එක මේ එකපාරක් measure කරා තව පාරක් time එක measure කරනවා වගේ වැඩක් තියෙනවා. එකපාරක් measure කරනකොට මේ වගේ error එකක් ආවා. ඊළඟ පාර measure කරනකොට ආයි ඒ වගේම error එකක් ආවා. ඒක total error එකක් කියන්නේ ඔය errors දෙකෙන් එකතු. හරි ඒක නිසා මොකක් හරි power එකක් ආවොත් ඒ power එකේ සමාන errors ගණනක් add වෙනවා. ඒ power එකේ සමාන errors ගණනක් add වෙනවා. පැහැදිලිද ඒක? තේරෙනවද? හරිද කියන්නේ? I need responses from everyone. I need responses from everyone. හරි. Derive this one. මේක ෂෙයාර් කරමු. මේ ක්වෙස්චන් එක 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 විදිහට අහන්න පුළුවන්. මම මේ විදි කීපයක් හදන්නේ. What is the variable? That should be measured more accurately. What is a variable that should be measured more accurately? ස්ලෑෂ් එකක් දාලා ලියා ගන්න ස්ලෑෂ් එකක් දාලා ලියා ගන්න. ඒකට මේ වගේම තව ක්වෙස්චන් එකක්. The accuracy of simple k. The accuracy of simple k mainly depends on capital T. The accuracy of simple k mainly depends on capital T. What would be the reason? What would be the reason? ये क्वेश्चन එක මම වෙන විදිහකින් අහනවා. සාෂා දාලා ලියාගන්න. සාෂා දාලා ලියාගන්න. What is the factor? What is the factor that has the highest influence to the final result? What is the factor? What is the factor that has the highest influence to the final result? Well, we did only thing I had. Okay. Can I answer one? Measuring of capital T. Measuring of capital T. Capital T is the factor. Capital T. Reason, no then. In this experiment, there is T square in this in this expression, the experiment A, in this expression, there is T squared. In this expression, there is T squared. T squared. Therefore, if the error of measuring capital T is equal to delta T, then the error of measuring T squared is equal T into T නෙමෙයි. මෙයා delta T error එකක් එනවා. මෙයාගේ delta T error එකක් එනවා. එහෙනම් total error එක delta T plus delta T is 2 times delta T. 2 times delta T. Therefore, T squared highest error in measurement. Therefore, this should be measured very accurately. Therefore, It should be measured. Very accurate. Okay. Then there is next question putih. Ila question ka. During this practical, during this practical, during this practical, we cannot obtain y equal mx type graph. We cannot obtain y equal mx type graph. Instead of that, we will have y equal mx plus c type graph. Instead of that, we will have y equal mx plus c type graph. Okay. Ila question during this experiment, we cannot obtain y equal mx type graph. During this experiment, we cannot obtain y equal mx type graph. During this experiment, we can't obtain y equal mx type graph. Instead of that, we will have y equal mx plus c. Y equal mx plus c type graph. Y equal mx plus c type graph. What would be the reason? What would be the reason? Makan reason again. Actually, the reason is okay, that mass holder has a mass. Okay. So when you are adding another mass into that mass holder, so actually before we add in another mass into the mass holder, it had a weight. Therefore, due to the weight of the mass holder, the helical spring can stretch a little bit. Therefore, once you add another mass, the total mass should be the added mass plus the mass of the mass holder. So in this case, Pute, we did not consider the mass of the mass holder. We neglect that thing. We neglect that thing. But the thing is that cannot be neglected. That cannot be neglected because that has a mass. That has a mass. Therefore, if you consider what the mass holder, okay. Uday, this is the mass holder. Uday, this has the mass no. So due to this mass holder, and once we suspend this mass holder through this spin, definitely it will have a deformation. It will have deformation. Therefore, we should consider that mass also. We should consider that mass also. Actually, that mass can be determined. The mass of the mass holder can be determined using a triple beam balance or any other equal balance. And therefore, we can determine this mass. So until that, we can rearrange the expression. So expression is equal b squared 4 5 squared over a plus n ne. So instead of m, I can put m plus m naught. M plus m naught put m naught means the initial weight of the mass holder. That is the weight of mass holder. So every time we have to add the weight of the mass holder plus the added weight. Therefore, total weight should be equal to the added weight plus weight of the mass holder. Mass of the mass holder. If you get that thing, please tell them to sir. Again. So this is the added mass. So this is the mass of the mass holder. Mass of the mass holder. එහෙනම් බොහොම පැහැදිලි පුතේ බලන්න a square is equal 4 pi square over k into n plus 4 pi square over k into n. Putte, m naught means that is a constant. The mass of the mass holder is a constant, Putte. Therefore, this should be a constant. This term should be a constant. Therefore, I can write this one as a constant. And this term, that is also a constant. Therefore, this relationship looks like y equal mx plus c type relationship. Y equal mx plus c type relationship. If you got that one, please raise the hand. Anything else, sir? I need responses from everyone. Do you know that we ended? Oh. M, X, C. Say that. Okay, there I know this. The mass holder already has a mass. It should be added to the total suspended mass. It should be added to the total suspended mass. Then we will have y equal mx plus c type graph. Then we will have y equal mx plus c type graph. මේ දෙනවා කුසල පුතේ එහෙනම් අපිට ඇත්තට මෙන්න මේ වගේ graph එකක් තමයි එන්න ඕනේ. හරි. It is very clear all those also are positive. Phi square means positive. K also a positive value. M not mass, that is a positive value. Therefore, definitely we have this kind of relationship. P square here mass. They are okay. Okay. Yeah. Then the last question. So it is adversible. It is adversible to it is adversible to stretch slightly. Underline that word. Stretch slightly. Stretch slightly the mass instead of instead of instead of large elongations. Large elongations. ඉතින් අපි මෙයාර පොඩ්ඩක් ඇදලා තරින්න ඕනේ. හරි. ගොඩාක් ලොකු ඇදලා තරින්න එපා. එහෙනම් මුතේ මේ ස්ක්‍රීන් එක ගියයි උඩට. හරි. හරි. So the reason instead of large oscillations. So what is the reason? Body here to make that. So if you use a small oscillation, if you use a small oscillations, then we can assure there are no any collisions between the turns of the spring. Actually, there are collisions between turns. So now initially this was stretched. So once this object is like this, and there may be collisions. There may be collisions between those turns. Therefore, if we use huge or large stretch, අපි පොඩක් පල්ලහැන ඇදලා අත්හැරියොත් එහෙම දුන්නකම වගේ උඩ පල්ලහැන සමහරලාට මේක දිලා උඩ සීලින් එකේ දින්නත් පුළුවන්. සීලින් නෑ නැත්තා ඒ කියන්නේ ඒක එක්ස්පෙරිමන්ටල් සෙටප් එකක් තියෙන්නේ. කලින් කරනවා ඔක එයාගේ තියෙන අර කන්ඩිෂන්ස් ඔක්කොම වෙනස් වෙන්න පුළුවන්. ඒක අපි දන්නවා. If we use a huge or large elongations, if we use a large elongations, there may be collisions between turns. There may be collisions between turns. There may be collisions between turns during the upward motion of the mass. During the upward motion of the mass. Therefore, there may be an energy loss. Therefore, there may be an energy loss. Helical. Do you have any questions regarding the practical? The practical again, what kind of question is there? Well, no. Alright. Then මම ඔයාලට ඉවවා practical equivalent එක practical equivalent කියලා කියන්නේ මේ practical questions ටිකක් මේ views වල 1991 වල ඉඳන් ඒකේ තියෙනවා 2008 question එකයි 2021 question එකයි 8 එකයි 21 එකයි අන්න ඒ දෙක දැන් කරා අනේ ඒක දැන් දැන් ප්‍රැක්ටිකලි ඉවරයි. 2021 එක පුතේ මුලින් ගන්න ටක් ගන්න. 2021 එක මුලින් ගන්න ටක් ගන්න. 2021 එක ටක් ගන්න. ඊට පස්සේ 28 එක. Okay, බලමු. මේක ඇත්තට අමාරු ප්‍රශ්න නෙවෙයි. A mass simple M is suspended by a helical spring with a pointer attached at its lower end, as shown in the figure A. Figure. A student is asked to verify the relationship between the mass M with its period time capital T of vertical oscillations and determine the spring constant K by using the graphical method. Write down the expression of T M and spring constant K. And I'm going to expression again. T equal to 5 square root M over K equal square root number 1. That is 2021. And our first question again equal to 5 square root M over K. So this is the relationship. Number 2. Rearrange the relationship written in A1 above in order to verify the relationship between again make a rearrange කරන්න කියන්නේ graphical method එක. Graphical method එක rearrange කරොත් මොකක්ද වෙන්නේ? T square is equal 4 pi squared over K into M. Third, sorry, give a numbers දාගමු. This one A 1 2 now B. If the student is provided with set of 50-gram weights, what is the other essential measuring instrument that he needs to do this experiment? So what is the answer? දැන් මේ ඔක්කොම ටිකක් දීලා weights එකක් දුන්නා මොකක්ද ඊළඟ instrument එක වුනේ? මොකක්ද ඊළඟ instrument එක වුනේ? What would be the answer? That the students is given all the necessary equipments, helical spin, then weights, then pointer and indicators all are given. So what is the other instrument he needs? Definitely stopwatch. No, because there's no evidence of a stopwatch. Therefore, definitely there should be stopwatch. Yes, a stopwatch. There should be stopwatch. It is advisable to use a locating pointer a pointer in this experiment. Draw an arrowhead that is the appropriate position of this pointer in the above figure. So in the above figure, okay, definitely there may be this kind of thing. So this is the indicator, it is given. This is the indicator, it is given. Therefore, definitely the pointer is on the stand and it should be pointed. It should be pointed in line with the indicator. Indicator takka in line with the giving your hand. What is the purpose of using this locating pointer? So what is the purpose of using locating pointer? To count the number of oscillation, no? To count the number of oscillation. To count the number of oscillations. So that is the requirement of this pointer. That is the requirement of this pointer. C. Ne? C1. Why does the accuracy in determination of the string constant K depends mainly on the accuracy of determination of period of time of oscillation of the mass? මොකක්ද හේතුව? There is t squared term, no? There's a term t squared. There's a term t squared. Therefore, the error in measurement. Two times delta T දානකොට පොඩි delta තියෙන්නේ. Delta 2 times delta T. Delta T කියලා කියන්නේ error in measurements of 1T. මෙහෙම ළමස් තින් බලන්න. ගොඩක් ලියන්න එපා. අවශ්‍ය දේ short test විදිහට. Then, what is the characteristic property of the instrument mentioned in B1 above, which affect the fractional error of time measurement? Net value of property is B1 වල තිබෙන මොකද්ද stopwatch එක. stopwatch එකේ මොකද්ද තියෙන property එක fractional error එකට affect වෙන කියලා හරි. Definitely the fractional error should be equal to the least count over the measurement. Least count over the measurement. Therefore, there are only two factors that influence the fractional error. One is least count, other one is measurements. So you ask the property of the instrument that can affect the fractional error. Therefore, definitely there should be the least count of the stopwatch. Definitely should be the least count of the stopwatch. Least count of the stopwatch. ඒ දෙනවා තුස්සන්. ඒ දෙනවා තුස්සන්. fractional error එක තියෙන්නේ කොහොමද factors දෙකයි. factors දෙකේ එකක් කොහොමද මේ measuring මොකද measurement එක එහෙනම් ඉතිරි factor එක තමයි instrument එක නදාගන්නේ. Third one. Let the appropriate type oscillation, let the approximate type oscillation is to be T. Write down an expression for the minimum number of oscillation N that should be taken in terms of X and T in order to obtain the percentage error. අර කතන්දරේ තමයි හරි. අපි කතා කරේ. So fractional error. Will be equal to the least count divided by measurement. No? Now the fraction error should be less than 1 over 100. It should be less than 1 over 100. Oh, that is the maximum value, right? 1 over 100. 1 over 100. So least count is given as x. Measurement. Measurement means okay. Let the approximate time for oscillation be t. That means oscillation period is t, simple t, that is given. So if it is t, then the number of oscillation is n. The measurement should be n times t. No? මේ oscillation එකක time එක මේ number of oscillations ගන්න. එක oscillation එකක time එක number of oscillations ගන්න. Therefore, this is the total time taken for the n number of oscillations. Time taken for n number of oscillations. Therefore, that is equal to 100, 1 over 100. Therefore, n should be equal 100x over t. තේරෙනවද පුස්සන්නේ? හොඳයි. ඊළඟට අහන්නේ පුතේ calculation එකක් අහන්නේ මොකද්ද calculate the spring constant k. K calculate කරන්න කියලා තියෙන්නේ. Therefore you need to determine the gradient. මම මෙතන දැන් gradient එකට හොයන්නේ නැහැ ඒකට තියෙන්නේ ඇත්තටම. ඔයාලා බලලා ඒක හොයන්න. පුතේ බලන්න මම හොයන්නේ හැටි කියන්න. So when we are determining gradient, take two different points as you have to take take maximum separation. Please take the maximum separation as much as possible. But remember, when you are taking 2 points, those 2 points should be readable. Readable points දෙකක් ගන්න පුළුවන් තරම් ඈතින්. Readable points දෙකක් ගන්න පුළුවන් තරම් ඈතින්. මේක මම හිතන්නේ x1 y1 කියලා ගන්න. මේක x2 y2 කියලා ගන්න. Therefore gradient මම කියලා දෙනවා කියලා gradient එක හොයන්න ඇති. නේද? අපිට දුන්නොත් එහෙම මේ වගේ Cartesian coordinates දෙකක් gradient හොයන්න ඕනද? y2 minus y1 divided by x2 minus x1. එකම පැත්තට ලු කරන්න. එකම පැත්තට y2 minus y1 ගත්තොත් x2 minus x1 ගන්න. උත්තර දෙනවා. So that is the gradient. That gradient should be equal to 4 5 squared over k. This gradient is equal to 4 5 squared over k. 5 squared අපිට ගන්න කියලා නේද? ගන්න 10 කියලා දෙන්න. 5 squared 10 කියලා අරගෙන ගන්න. 5 squared 10 කියලා හදලා ඒ වගේ. Therefore, k should be equal method of 40 into k. 40 into x2 minus x1 divided by y2 minus y1. ඔයාලා දාගන්න ඔයාලට කැමති x1 y1 x2 y2 වගේ දෙයක් ඔයාලට කැමති දේ දාගන්න. ඔයාලට කැමති දේ දාගන්න. හැබැයි ඒක දාගන්නකොට පුළුවන් තරම් ඈතින් දාගන්න. පුළුවන් තරම් ඈතින් දාගන්න. හැබැයි දාන එක රීඩබල් වෙන්න. රීඩබල් එකක් ගන්න. ඒ රීඩ් කරන්න බැරි දේවල් ගන්න එපා. ඒක මොන්නේ. ඊළඟට last question. Give the reasons for obtaining non-zero intercept. අපෙන් අහනවා non-zero intercept. අපි කලින් කතා කරපු කතන්දරේ. දැන් හරියට y equal mx right back ඉන්නේ නැතුව y equal mx right back ආව නම් පුතේ intercept එක 0 නේ. So what is the reason to have non-zero intercept in this graph. So that is the reason, no? Because in this equation we are not added the mass of the mass holder. There's a mass in the mass holder that should be added. That should be added. Okay. Therefore, if we add that mass, then the intercept cannot be zero. Intercept cannot be zero. Mm. Mass of the mass holder should be considered. So another done. There's a mass in the mass holder. There's a mass in the mass holder. And it should be added to the total mass. It should be added to the total mass. Therefore, although we anticipate y equal mx type graph, we will get y equal mx plus c type graph. We will get y equal mx plus c type graph. Although we anticipate y equal mx type graph, we will get y equal mx plus t type graph. Theorem. Password question එක අමාරුද? අමාරු නෑනේ. ලේසියි. මේකයි කියන්නේ ප්‍රැක්ටිකල් කියන කතන්දරේ පොතේ හරියට කොට දාගත්තොත් අනිවාර්යෙන් ෆුල් මාක්ස් ගන්න පුළුවන්. හරියට දාගත්තොත් අනිවාර්යෙන් ෆුල් මාක්ස් ගන්න පුළුවන්. ඒ නිසා ප්‍රැක්ටිකල්ස් වලදී අනිවාර්යෙන් වෙන්න පුළුවන් හැම විදිහකින්ම අපි හිතලා ප්‍රැක්ටිකල් එක කියලා දෙන්න ඕන. සහ වෙන්න පුළුවන් හැම විදිහකින්ම හිතලා ප්‍රැක්ටිකල් එක ඔයගොල්ලෝ ඉගෙන ගන්න. හරිද? එහෙම වුණොත් වෙන ඕන ක්වෙස්චන් එකකට ආන්සර්ස් දෙන්න පුළුවන්. වෙන ඕන ක්වෙස්චන් එකකට ආන්සර්ස් දෙන්න පුළුවන්. ඒ නිසා බය වෙන්න එපා. හරියට ප්‍රැක්ටිකල් එක කරලා මානව ලේසි ප්‍රැක්ටිකල්ස් වලින් හරිම ලේසි ප්‍රැක්ටිකල්ස් ටික. හරි. වැඩි තේරෙනවද නැතුස්සන්? හරි. මේ ගෙලිම එක්සම් ක්වෙස්චන් එකක් කරේ හොඳට. ගෙලිම එක්සම් ක්වෙස්චන් එකක් කරේ. හරි. Okay, so we can conclude today's lesson. Now you can go with 2008 question. Then you can send the answers to me. Then I will send the marking scheme. So you can mark your answers. Okay with it? Okay, everyone. Good night, Putin. Bye. Thank you, Putin. Good night. Welcome, Pratik.